Hey, hello, welcome everyone. I'm Dave Rubenstein, editor-in-chief of SD Times and host of today's program, Why You Shouldn't Use a Relational Database for Time Series Data. Before we get started, I have a couple of quick announcements. Today's program will be followed by a live Q&A, so you can ask a question at any time during the presentation. Navigate it to the control panel, go to the questions tab, type your question, hit submit, and we'll get to as many as time will allow. Secondly, today's program is being recorded and will be available on demand within the next 24 hours or so on the sdtimes.com website. So with us today to discuss the benefits of time series databases is Daniela Ponce. She's part of the product marketing team in InfluxDB in San Francisco. Having worked in various market segments from embedded smart antenna technology to internet security and e-commerce, doing product management, partnerships, marketing, and business development, she has a broad experience working cross-functionally and with customers and partners. So let's get right into it. Here's Daniela Ponce.
Okay. Hello, everyone. This is Daniela Ponce. I'm part of InfluxDB product marketing team, and I'm here today to talk to you about why you should not use relational database for time series data. To guide our, just a second, everyone, I need to move something. Can everybody see okay? Okay. To guide our conversation today, I'm sorry about that. To guide our conversation today, we are going to address four main topics, starting with why we collect timestamp data. And then we will talk a little bit what makes a time series and difference between time series databases. And we will end up our conversation talking about InfluxDB model. And this gives you a good example of what it means to be purpose-built. So why we collect timestamp data? Well, we have been doing this for a long time already. That's why we know how things are changing in our planet and how we know an economy is doing well or not. So what is the news here? The news is the amount of data that we are now collecting and how fast we are collecting, how granular we are collecting that data. And the reason is because we have three main drivers of timestamp data. One being the IoT. IoT is a big umbrella, and we like to divide it into two segments, sub-segments. One is the industrial settings, and that includes, the legacy historian solutions that you have out there, monitoring sensors in the manufacturing plants, making sure the equipment function as it should, the output is reaching thresholds that are supposed to. But also includes, the big platforms, oil and gas exploration, and agriculture business that wants to know, how, the soil is behaving in terms of humidity and nutrients. So a lot of sensors are being spread all over the place and collecting data to better the way people do things. And we also have the idea of smart cities, smart roads, infrastructure that tell people, better ways to go through a city, avoid traffic jams, or find parking lots. So it's about also enhancing life quality. And another segment we find in IoT is the consumer segment. And these are the wearables and, all the sensors and all the devices that you have now in your house, guiding you in terms of better consuming utilities or making sure that your alarms are set up and functioning, or letting you know if the house is the temperature is controlled in a way that it's comfortable. And you have also all the wearables that you have today monitoring yourself. It's basically you consuming time series that is generated generated about you, and it's just packaged in a way that you can use it in a meaningful way, like telling you if you are walking enough, if your indexes are as it should be. Another area that exploded in terms of time series is DevOps. And what happened there was that the market pressure for feature parity, competition, being one click away, you're looking always to add functionalities that will differentiate the kind of services that you provide, or also monitor the way that you are providing that services. It's put so much pressure in the application development team that they had to break the big application into smaller pieces. And those pieces are services or microservices that they run in independent containers. And those containers are independent in a way that they perform a function, and that function passes over to the next one. And that creates a chain of effect for you to deliver the whole application experience. But the thing is, now you want to make sure that the pieces work together as they should and deliver an overall experience that is suitable and is acceptable. So what before used to be a set of 3-4 measurements or metrics that you needed to keep an eye on, and those being memory usage, CPU, network interface load, disk space. Now it's not just about the systems. You have to manage the same thing for your VMs, for your containers. And by the way, you need to make sure the containers, they are well managed. They come up and they disappear, and everything needs to be managed in such a short time, or measured in such a short time, that you need to make sure that you capture everything for historical reason, and to offer you an idea of trends that may be building in your application environment. But that's not all of it. You have now a huge pressure on the network that glues everything. So you need to keep an eye also on response time in your network. Make sure that the jitter is under control, the latency is under control, packet loss, error rate. And by the way, make sure that the bandwidth is consumed by those who should be consuming it, and at an acceptable level. So you need to monitor also flow per IP, per port, per protocol. And we are also working on identifying users and processes that are consuming bandwidth beyond what the threshold levels. So there is a lot being monitored in DevOps now. It's orders of magnitude more than what used to be. And of course, since you have so many pieces, moving pieces, appearing and disappearing, the overall experience needs to be monitored too. So there is another layer of monitoring on top of everything. And the third trend that we see, a driving force, is what we call real-time analytics. We are living an age of data-driven decisions making. And it's not just business, it's about our personal lives too. It's about everything that we want to do. We need to have some kind of data supporting it. And that is driving the need for real-time. Real-time analytics means that you need to be very fast, and you need to have sampling rates that is really granular, so you catch on things as they happen. And that just multiply, the amount of data that you are collecting by an unprecedented amount. So just to support, as we are talking about data-driven society, just to support what I have been saying, this is a survey that shows that about 80% of the interviewed target declared that they already do some kind of collection of timestamp data. So it's something that is already there, it's happening. You just need to find a way to manage it well and efficiently. So is everything that has a timestamp time series? No. To be time series, it needs to be a collection of measurements of the same thing, exactly the same thing over time. And that's what makes a series. And series can be regular or irregular. Regular is when you collect or you get that measurement on intervals, time intervals that are the same. They don't change every second, every minute or day, whatever, but everything is collected at expected time intervals. And a series like this would look like this blue line on top. Another kind of time series is also something that you do, like you measure the same thing over time, but the times when you get that information, when you collect that information is not consistent. It could be at any time. It happens when it happens. And if you graph that information, that series, what you would have is something like in the bottom, the red line. You have one sample here, another one could be in 5 minutes, the other one could be right after, a couple of seconds after, and you could have a long time before you have another one, and so on and so forth. When we have regular time series, we associate to metrics, something that you are measuring at regular times, and that is very common to use in monitoring infrastructure, like containers. Monitor the CPU load, the memory usage, the disk, all the usual suspects. You go there and you get that information on a regular basis. Irregular time series are usually called event time type of time series. And what is going on here is it could be anything. Not when we talk about events, we just think about bad events. Yeah, like something broke, some failure, some error rate that is starting to show up. But it could be also good things that you want to monitor, but you don't know when it's going to happen, like a click. You wanted to understand how your user base is interfacing or interacting with your application, your new feature, or a new icon that you made available in your UI. So this is also an event, and this is also part of a time series, since you are monitoring the same thing over time. So events can be anything. One aspect of time series is that all the data that you collect comes with time, and they are collected over a window. And you can do a lot with that kind of data. One of the things that you could do is summarization. Summarization is you get a window sample, and from that window sample, you extract another sample that could be a sum of counters that you have there, or you could perform an operation and just represent that data, collecting that time space as a representation of that data through the operation that you executed. That's called summarization. And with that technique, you can transform a irregular time series into a regular time series. And another nice thing of it is that you can transform raw data into processed data. And with that, you can reduce significantly the amount of storage that you need for that data. There are certain data that you need, in raw format, when you collect, but as time goes by, you may not need that amount or that granularity of data. So let's see what we know about time series, because this is important in order to design a solution that knows how to handle it and takes advantage of characteristics that stays constant or consistent across the data that you are collecting. First, that you have a timestamp there, and the time is your guide. It can guide you in many different ways, and one of them is how you're storing your data, sequentially in terms of time scans, and that will help you a long way when you want to query that data. We know that it could be regular or irregular, so applying summarization, applying some kind of technique to transform irregular to regular is something that you could do, and you should make available. The idea here is to understand the various use cases. Make sure that you make available to who is going to use the time series techniques that will enable them to extract the most information out of it. And understand that we are talking about huge volumes of data now. It's when you're talking about, financial markets, gaming industry, where basically you have a race there. Who knows first, who sells first, who buys first. So we are talking about nanoseconds here, kind of sampling data. So you cannot do the things that you do in this type of volume with the same tools that you had in the past. Or you could do, but not efficiently and not in a manner that will provide you timely information. And understand that time series, timestamp data, they have different kind of values over time. You have some certain kinds of measurements or metrics that you collect. They have a very, very important value at the collection phase or at the collection time, but that value can decrease over a week or month. So you should be able to aggregate that data, do roll-ups, and make sure that you just store what really represents value to you. So you have real-time data that you can act on, do analytics on, and you can also manage the sensitiveness of that data over time. And all of that should be made available to you as part of the design of your time series platform. So what it means to be a time series database? It means to be optimized for the collection, storing, retrieving, and processing of time series data. You need to take into account that the type of data that you are collecting, that you are storing, retrieving, and processing when you design your solution. So you are efficient, you are fast, and you provide timely information. So you allow preemptiveness. Yeah, what is the point of monitoring something that you cannot anticipate the call? On the right side, we show that we are talking about specialists. We have been talking about specialists for a long time already. We already have in the database space, document database, search database, and the traditional relational database. But that's not all. You have what's called a graph database. You have object-oriented database. You have key-value database, multi-value database. So, and there is a reason to be. When you take into account the type of data that you are going to handle, you can make decisions about what you are going to prioritize in your design and what you're going to kind of compromise. There is no always win-win. Sometimes you have to decide between one dimension or the other. So here is just some examples. We have on the left side what we are calling here other types of database, and those are some names that you must be familiar with. They are very popular database, Cassandra, Mongo, Elastic, Redis, key value pair kind of database, Cassandra for distributed storage. We have document database like MongoDB. Elastic is a document database with the key value stored on top of it for full search type of capabilities. We have Redis for speed or in memory. So you have, your options of other types of database. And in terms of time series database, we already have specialists. KX, for example, they optimize for speed. It's mostly done in memory. So for that reason, they target the financial market. We have Open TSDB, which is also a key value store on top of HBase. We have Graphite, which is an old, kind of a legacy time series database, one of the first to come up and did a good job. but they didn't anticipate the volume that they would have to handle, and they didn't anticipate the value of storing data for a long time. So a lot of the graphite deployments now are facing scalability issues. Yeah, we have also React for distributed remote centers. So everybody found a way to provide additional value by making decisions that optimize for a certain aspect of managing time series. So, but at the end of the day, what people do is what they do, and they favor, what they know. So this research shows that about 60% of the people interviewed say that they continue to use relational database to persist time series data. What is wrong with that? Nothing. If that's serving you, is something that you know how to handle, that's okay. If you grow in volume, if you grow in storage requirements, then you are going to have to make decisions in terms of how much you want to pay for those storage that is not optimized for time series. Can you handle the volume and the query, simultaneous queries that you may be hit with? The experience may, demand that you need to look into other things. So as of today, there is a mix of choice. About 12% already opt for a specialized time series database, but there is a big a number of people that are still, trying different solutions to fit into their use cases. And there is nothing wrong with that. When you know what you want to do, that's when you need to make decision about what kind of design will deliver the best results for exactly what you want to do. So here is just to show you that among, the time series solutions that are there, time series that are in the market proposing to be an option for handling time series database. InfluxDB has the largest adoption rate. And we have also some DISON reports that are released monthly that shows clearly that inside of that segment of time series, InfluxDB is the preferred choice. And we are going to talk a little bit why that would be the case. And it's basically because it's purpose-built, but in which way we make decisions that provide better results for managing time series. So why Flux data, enjoys so much attention and is the preferred. So here is what we call a platform strategy. It's because when InfluxDB was designed, it was designed taking into consideration the driving force that are generating time series data. And so where they're coming from, in which format, in which way they are being collected, that's very important. Which teams, organization, and audience that information or that time series is serving, that is also very important. And what else, what other, I would say, frameworks or solutions would benefit from time series? So we took into account all these aspects of the potential use case for time series to create a platform that is optimized for instrumentation, observation of the data, and how you can learn from that data. And then the ultimate goal is automation. Yeah, so automation allows you to anticipate, reduce costs, and to do things in a more smart way. So let's dive into each one of these aspects. In terms of instrumentation, you need to understand that we are talking about very ingest high rates. We are talking about millions of writes per second. So you need to make sure that you can do that efficiently. And we are also collecting data from everywhere. We talked about IoTs, but IoTs is quite different from the data that you are collecting from your data centers, from your containers, from your VMwares. And again, it's different from the kind of data that you would need to process to provide real-time analytics. So all of this needs to be taken into account. I give you an example. When we design, the data format to collect the data, we understood that you want to collect the measurement, but you want to collect also metadata about that measurement. And that metadata can vary in terms of quantities that you need in order to isolate that measurement for reporting purpose or analytical purposes. But also we understood that you may be in situations where collecting the data at the source is just the beginning of it. You still need to send that data all the way back where it's going to be ingested and processed in the time series. We are talking about sensors located remotely that they need to be optimized to send the information in a way that you also consumes little bandwidth. Some of them are using GSM cellular networks. So you cannot be, I would say, you cannot just disregard the fact that you should collect them as much as you can and send in one go instead of using that channel multiple times to collect different aspects of the same measurement. So the data format that we apply that we have for InfluxDB time series allows you to collect multiple tags and multiple fields, so you can collect the various aspects of your CPU in one go. That's one way of being efficient about instrumentation. Another thing is when you get that data in, that data is immediately compressed. And this is already allowing you to ingest and write and store more of that data. So, and all of that speed needs to, ingest speed happens when you are doing real-time query. So you need to be smart about, how you place that data inside of your storage structure. So the query is also easier and faster. So series or collection of the same type of, which is the same type of data over time, they should be stored in time-bound files and make as large as you can. So for larger scans, you don't go over different files that may be in different nodes, but you get everything at once and fast. So this will help you in providing real-time queries in tens of queries per second and hundreds of queries per second at the same time that you're ingesting millions of metrics per second. So once you have all that data coming in, you need to make sure that you enable that learning process, making sure that you can feed also other frameworks. So being in an open source is fundamental. You are not isolated in a silo where everything is hard to see and to figure out, and how you're going to integrate depends on so many things that you don't have control or visibility into. So being a platform that is open source also provides you the windows to all these other frameworks that could benefit from time series. And we are talking about anomaly detection, machine learning, artificial intelligence, so on and so forth. And also the whole stream analytics that you can do right from ingest, making sure that the data that you keep, it's already processed data that will be more conscious of resources utilization. And in terms of automation, it's something that sometimes is not talked about, but is so important. It's important important, even with regards to, when you are going to downsample that data or evict that data. So when you start collecting time series, you will end up with a lot of data if you don't manage the life cycle of that data automatically. If you're managing one or two series, okay, yeah, you can go there. It's time to evict. It's time to roll up. It's time to do this and that. But we are talking about millions of series. This needs to be automated. Needs to be part of the design of your time series platform. So everything happens as it needs to without, manual interaction. Evicting data from a relational database, evicting data, time series data from a relational database, it would not be easy. You would find pieces of information here and there. So in time series, thinking of that, you need to make sure that when you evict, for example, you evict the whole shard. So you need to make sure that your policies are aligned with the automation that you need to do, retention policies with eviction, with downsample. Everything needs to be in a programmable way and definitely automated. So what InfluxDB offers an open source platform, which is about 3 projects. One is in the center, one is InfluxDB. It's available for you, free. You can just download and use everything that is, it's all the feature complete. And it's a purpose-built time series database with all that, design aspect that makes, time series a first-class citizen. It comes also with 3 other projects, open source, free to use, to contribute. First one is Telegraph, which is the agent, as we talked about. The collecting aspect is very important. Bringing the data in is very important. So having a tool that's plugin driven and very easy to define or create new plugins. We have guidelines available and everything, and part of a community that is very motivated and enthusiastic about it, grants you a menu of collecting options that it's really easy to start with. So Telegraph has more than 200 plugins for all kinds of applications that you find already in your environment. And if you need to write one, you will have a whole community behind you to help you. We have also Chronograph, which is the visualization tool that can query into InfluxDB and provide you with dashboard that that will guide you in terms of observing what's going on and the metrics that you care. It comes already with pre-canned dashboard for the usual suspects, so system stats, Kubernetes, network monitoring is already there for you. And we have Capacitor, which is the real-time streaming data processing engine for you to allow you to define your alerts and to also to aggregate data at ingest. That's very important. So when you bring in the data, you already process that data for optimized storage. And on top of the open source platform, InfluxDB as a company provided deployment options with value added that is paid for. We have the enterprise version, which with the clustering, manageability, and security as additional value to the open source platform. And we have the Influx Cloud for those that don't want to host their infrastructure, that want to start already in the cloud environment. So here is the architecture, just to put the pieces together in a visual way so you can understand exactly how things are flowing. On the left side, we have Telegraph, the agent, and here I have on the very left the type of plugins that is already there available for you. It's more than 200, but there are and I say there is more because about that number is what is officially part of the supported community. But there are lots of other plugins that are really brought in for a special use case or personal, people that use your personal time to create plugins to, manage your things that, for them it would be an interesting thing. So there is a lot there already for you. And if you need to add your use case, certainly you get a lot of support. But just to start with, you already have Kubernetes, database and application that you usually find in your environment, like, MySQL, Apache, Nginx, so on and so forth. Networking plugins like SNMP, Ping, to make sure that your network is performing as it should be. We also have integration modules for flow monitoring. Prometheus endpoints can be totally managed through InfluxDB. Telegraph can do the polling, monitoring to those endpoints, and send everything in batch to InfluxDB, adding to that value, because Prometheus is metric based. But with Telegraph, you can also listen to events. So if you have Prometheus, great, they do a great work with regards to metrics, but you can always get more or augment your monitoring with Telegraph along. So you can also get events from your application environment. Logs and trace, yes, why not bring in? We believe metrics first. Metrics, it's in the events, that happens in real time is what, will trigger your actions. But logs and trace are very important too for you to guide you to root cause analysis. We have syslog plugin already ready for you to start bringing your syslog data to InfluxDB, and we have already a dashboard for that information. There is some plugins also being written for tracing. So there is a lot. You can basically bring everything that's timestamped that you need to monitor over time to InfluxDB. And from there, you can visualize, you can aggregate, you can do a lot of things because you have all together. You can build the whole picture there. All this data that is being collected can be sent straight to InfluxDB or also to Capacitor for aggregation at ingest. Capacitor can query InfluxDB on hot data in mem, but also store data, and you can do those analytics on both, merging both. And Capacitor is the interface for your alerting frameworks or anomaly detection, machine learning, artificial intelligence, anything else that you want to do with that data that you have been collecting. And Chronograph, as I mentioned, the visualization tools already comes with precans for Kubernetes, network, system stats, and some applications that are very popular. So let's wrap up with summarizing why choose InfluxDB as your time series. First is because it's very easy to get started. From my own experience, when I first knew about InfluxDB, I went to the site, I downloaded to my Mac, and 15 minutes later, I had InfluxDB running. I had Telegraph running and collecting the system stats from my computer. I had Chronograph displaying the dashboard on what I was using. It's really zero pain starting point. Use a familiar query syntax, is SQL-like, so it's very for you to get started and understand what's going on and get the feeling for it. Is really easy. It doesn't look strange. You don't have to understand different ways of thinking. It's very familiar. No external dependencies. Uses one download, one install, and scales horizontally. You don't have different node types and this and that. It's the same InfluxDB that you can add to your cluster, and it's everything is very simple. Manages both regular and irregular time series. That is so important because sometimes you don't realize the different types of data that you are collecting and how they are being collected. So you do need to keep in mind that it needs to be able to listen as well as pull. And InfluxDB doesn't come along. It comes as part of a cohesive time series platform in a very motivated community, open source community. It is already integrated with many other applications and frameworks, applications that would benefit from a very efficient and fast time series. So it's really, I would say that starting with InfluxDB is a safe and easy start. You can start with very simple metrics monitoring, even Prometheus time of metrics monitoring. Just for that is already good because you can start free. You can start, at any moment. You can download anything and start collecting. Most of the stuff is already out of the box. It's already tested by a large community and works, and it's already delivering value. So that's what I had for today, and I open for questions.
Very good. Thank you, Daniela. I would like to remind all of our attendees, if they have a question, they should type it into the control panel now. And again, as I said earlier, we'll get to as many as time allows. We already have a couple that we can get started with. And one of the questions I think is interesting, and it's like, so what is your query language like? And if it has time constructs that make it better or easier to work with than SQL?
It is SQL-like because the syntax that you find select and from, and so it's easy to understand how to query, but the fact that it takes into consideration the way that the data is collected and stored makes it very easy to group by the tags that you're collecting, to fetch the data in the chunks from one specific files instead of collecting data from different files, sometimes spread all over the cluster. So it is a very effective language for time series. And we now have a new version of it, an upgraded version, it's called Flux, which will allow you to do cross measurement analytics. So it's not just about having in the query language that capability to do analytics in terms of aggregation, summation, some kind of statistical transformation in that measurement in a fast and effective way, but also tap into different measurements to add to that analysis and create new value out of the collective measurements of different kinds of data that you are bringing into a one place. So that is really powerful.
Mm-hmm. Excellent. So another question is, so what about archival policies for the data? Is there automation for that?
Yes, that's super important. That's what I meant at that automation phase. When you define your measurements, your in InfluxDB, you define also the retention policies, and you define the shard size. And that will guide everything. Will guide the way that you will store that measurement for long term, the way that you will roll up that data, or the way that you evict that data. And that is very important to be automated, because as you add in terms of different kinds of time series and measurements that you need to monitor, you need to have that taken care for you as part of the time series processing.
Mm-hmm. Good. All right, another question is, do you have a public repository that can be viewed with all of your automation scripts and your work?
Yes, everything is in the GitHub project repository, but you can also have download from our website in our resource. You can download InfluxDB, Telegraph, Chronograph, Capacitor, and you have access to all the plugins available for Telegraph. You also have access to the libraries in the most common languages out there. We have in Python, we have in C, and we have in Ruby. So everything is available, very easy to access to install and start using.
Mhm. Great. Somebody wants to know, here's an interesting question. Well, what about Elasticsearch? There's a big trend in using that for time series. Is that true?
There are lots of solutions out there that propose themselves as a possibility for time series, and there is nothing wrong with that. You have a storage engine and you have a column for time. Yeah, sure, you can do that. You will be able to query back on that column. But the point that we make is that are you making the right decisions with regards to how you are storing that data so your query time is fast, the way that you distribute that data is consistent, it favors that query back, favors eviction, favor management that data. Elasticsearch is a document database with the key value full text, actually with a full text search on top. And they are optimized for that. They ingest a JSON document, they parse that data, and they store that data, that field in a document format. When you are monitoring things, when you want to have information real time, metrics first. Metrics means that you go there, you put the data, you pull the data, or you listen to that data, specific data that you care about, and you have that data ready for you. You don't have to search into a vast set of information to use that data. You already targeted that data to give you the information that you need. And if the information is for you to take action, better have it real time.
Mhm. So you mentioned monitoring, and another question came in, and that was, can you use influx data as a network monitoring solution?
Definitely. Definitely. We already have plugins for that. Network monitoring, it's utmost kind of importance today because they in the development environment, with the application being pulverized into smaller services, microservices running on independent containers. Containers could be in different nodes, and so the network is what is connecting everything, making sure that what is now broken into pieces work as it used to be as one. So we have, you need to make sure that the network, three pillars of network monitoring are in place for you. First is availability. You need to check if you can reach from source to destination. Second is the performance of that network, the response time, the error rate, jitter, delay in that network is under the thresholds that you is acceptable for the applications that you have in place. That will vary. And you need to make sure that the flows that you see in that network are the ones that should be there, and they are using the resources that they should be using. They are not wasting or consuming your bandwidth inappropriately. And these three types of monitoring you can do today with InfluxDB and Telegraph and our integration module. So you have SNMP plugin for Telegraph, and with that you can collect a lot of information about your network interface, about your appliances out there. You can go into the system stats, but you can also get information about specific OIDs determined by the network, by the vendor, whatever metric they say that would be important for you to monitor. you can do that already with our Telegraph SNMP plugin. We have Ping plugin that can give you information about latency in your network, packet error rate. You can get information about jitter. So you can monitor the responsiveness of that network. And we have also integration with NTOP, which does, it's a packet analyzer. So you get information about the flows itself, what is hitting your network interface and consuming your bandwidth. You can get information about flow per IP, per port, per protocol, and we are working with them to use eBPF to also tell you exactly who are the users that are consuming the network bandwidth and the processes. So when you take action, you take targeted action. So that's there for you in terms of network monitoring. And to be honest, it's what you need in order to keep a health, application environment running with the various distributed containers and microservices that you find now.
Absolutely. Very good. All right, so we're coming up around, I guess we have about a minute left, so I just want to throw it back to you, Daniela, and see if there are any final thoughts or takeaways that you have for our attendees today.
It's just that first you have, I think I would wrap up saying that time series is kind of a combination of two worlds. First, you need to think big. Don't think that the volume is going to decrease or you're going to be easier. You're going to get more and more demands for monitoring specific data because we are a data-driven society. We are going to reach a point where we cannot make a decision if we cannot back up with some kind of historic analysis of decisions prior to that. But also needs to be simple and easy, because of that dynamic aspect of adding more and more and making sure that, and augmenting, bringing others in. So you do need to be simple. And these are the two key values in terms of the time of influx data design. We want it to be easy and simple, so you can just start.
Fantastic. Well, Daniela, thank you so much for a very informative presentation today. I hope our attendees learned a lot about time series data and got a lot out of it. Again, I just want to remind everybody that this recording will be available probably by tomorrow on sdtimes.com if you want to listen to it again or at your leisure. So let me thank you, Daniela, for a great presentation, and thank Influx Data for sponsoring today's event, and also to thank our attendees who hung in there with us this afternoon. We appreciate it. And until next time, I'm Dave Rubenstein, Editor-in-Chief, SD Times. So long for now.
Thank you, everyone.